So for today, we are going to look into chapter 4, the piston engines. So with regard to the chapter 4, piston engines, actually we will cover the content for today in lecture number 5, and we shall continue the half part of the chapter in lecture number 6. So for today, we will look into the aspect of intermittent or piston engine, right? So we will look into the milestones of piston engine, the historical background of about piston engine, and then we will also look into types of aero piston engine that being used in aircraft, which include rotary engines, reciprocating engines, supercharged or turbocharged reciprocating engines. And for today, we will also look into the subtopic of aerodynamics and thermodynamics of reciprocating engine, ICE. I'm very sorry with my pronunciation. So, but we are not going to finish all of it, right? We will touch upon terminology of four-stroke engine as standard analysis and engine cycles, but we shall continue the part of engine cycles in lecture number 6, okay, to finish up on the topic of piston engine, okay? Right. The intermittent or piston engine, in our previous lecture, in the gas power cycle, we have already touched on the cycles of various types of engine, including piston engine, which is auto and diesel engine. So for today, we will look again, but we going to cover a little bit more deeper to look into the application of intermittent or piston engines. So as we know that the intermittent combustions or piston engines are one of the type of having shaft engines. It is sometimes identified as aero piston engines to differentiate it from the normal automotive piston engine. Okay, so the application of aircraft or aero piston engines can be classified into 3 types. One is the rotary type of engine, the second one reciprocating, and the third one is supercharged or turbocharged reciprocating piston engine. So aero engine may power small aircraft, at the same time also powering helicopters. And small airplanes have one or more piston engine connected to the propellers, which provide thrust to move the aircraft on the ground as well as through the air. All right. So piston-powered aircraft or helicopters most commonly use the 100-octane low-leaded fuel. Right. They cannot just simply use any type of RON type of fuel. Okay. They use normally 100-octane low-leaded fuel. So the next table that I'm going to show you, table 4.2, will provide statistics for present and forecast of piston engine. So we have a data from year 2000 until the projection up till year 2032. Right. So this forecast, I took it from the book, the table, the information coming from the FAA aerospace forecast. And they are looking at the data from year 2012 until 2032. All right. So what we have here is basically information on the application of engine, different type of engine. For example, piston with single engine or multi-engine, right? And then we have turbine type of engine, either turboprop or turbojet. And this is application for the fixed wing. And then we have application for rotorcraft, for helicopters. There are 2 types. One is the piston type of engine and the turbine type of engine. And this also show the total number of piston as well as turbine engine. As you can see here, it is now we are in year 2024, right? So the data is a projection, okay? But what we can say, it is at the right track in terms of the number of piston engine and turbine engine. It is quite, you can see that turbine engine numbers are growing, right? And steadily, the piston type of engine are reducing. But not, it is still significant. We still have a ratio of 1 to 3 in terms of turbine type of engine and compared to piston engine. All right. Aircraft powered by jet engines are nearly 10% of those powered by piston in year 2000. But you can see from the table just now, the ratio is expected to increase to 27.8% by year 2032. So you can see there is a increasing number of aircraft powered jet engine. The number of aircraft powered piston dropped by 10% in the interval of year 2000 until 2032, while the number of aircraft powered by jet engine increased significantly to 195% in the same period of time. All right. So what we can see here, many of the piston aircraft used for business typical fly relatively short mission, for example, like 300 to 400 miles at altitudes below 15,000 feet. And they are normally using very small general aviation airport that are often without air traffic control towers, right? For short traveling from what we call it as a city hopping type of mission. And helicopters are often attractive to business people because of their ability to land at a variety of heliports and outlying airports. Okay, let us look into the milestone, what happened historically. Okay, so since year 1903 and up to the first jet engine invented by Sir Frank Whittle as well as Dr. von Ohain. This is from Sir Frank Whittle from the UK, Dr. von Ohain from Germany. Piston engines were the only prime mover for the flight vehicle. So from the early beginning 1903. Later on, the jet engine took over and became the dominant prime mover or power plants employed in propelling aircraft. So I'm going to show you Appendix A, which provide a short list of piston engine employed in aviation field, starting from the Wright brothers. All right. So the font are a little bit small here, but I can just read it out in terms of the what's happening from 1903. We have the inline 4-stroke water-cooled 12 horsepower engine, okay, being used by Wright brothers, and then it evolved to 1925. We have Pratt and Whitney Worf's engine, and the horsepower are already increasing. And 1940s, we have Pratt and Whitney similar Worf's engine that are already being upgraded. Okay, and it continues from 1940s, 50s, 1970s, and the modern type of engine using piston, SMA engine, Diamond Aircraft Industry. Okay, so in industrial US aviation using Jabiru type of engine, and then more modern engine like Rotex 912 that being used in various type of aircraft, including Apollo Jetstar and Skyleader 200. As you can see that it is being like an evolution. You can see that different type of aircraft, Sikorsky, Piper, Cirrus, Cessna, Diamond, and so many that already being using the type of engine, a piston type of engine. Okay, let us look into more detail in terms of the types of Aero piston engine. We start with the three most famous piston engine, including rotary engines, reciprocating engine, and finally the supercharged or turbocharged reciprocating engines. The piston engines are further classified based on number of cylinders, and that's how it is being classified. How many cylinders of the piston engine, and then they also classified against the method of cooling as well as the cylinders arrangement. For example, like for cooling, regarding for the cooling, most piston engine aircraft are air cooled, right? This is to make sure that the engine are working at the right condition. However, there are also few liquid cooled engine are in operation. Of course, when you say liquid cool, meaning that you have to carry the coolant for to cool the engine, compared to air cool where we can just use the atmospheric condition. In both cases, either liquid cool or air cool, the excess air is transferred to the surrounding air, meaning that it will be transferring the heat, excessive heat, from the engine to the surrounding. In air cool, heat is transferred directly to the surrounding air, whereas a liquid cool engine transfer heat from the cylinders to a liquid coolant, which in turn transfer the heat to the surrounding air through the radiator. So there is another part here where we require heat being transferred to the liquid, and then the liquid coolant will be transferring heat to the surrounding via the radiator. Okay, two principles of piston engine. The first one is spark ignition engine. We call it as SI engine, piston spark ignition engine, which also identified as petrol engine or gasoline engine. And the second type of piston engine is compression ignition engine, or we call it as a CI engine, which is also identified as diesel engine. The piston engine can also be specified in two categories. One is the two-stroke engine, and the other one is the four-stroke engine. Right. Let us look into the three types of aero engine that I have already highlighted earlier. The first one is rotary engine. Okay, let us look into rotary engines. And over here you can see that the rotary engine itself can be classified into two categories. One is the conventional type, and the other one is the Wankel engine type, right? So rotary engine being divided into two categories. The first one, conventional type, right? The rotary engine, which was an early type of internal combustion engine, usually designed with an odd number of cylinders, normally 5, 7, or 9 type of odd numbers of cylinders per row. In a radial configuration. Okay, so in this type of engine, the crankshaft remains stationary. I will show you a picture of it, and the entire cylinder block rotated around it. Okay, so this type of engine was widely used during the First World War. Okay, and this is at the beginning of the evolution of the starting of the piston type of engine. They're using rotary conventional type, and the years immediately preceding that conflict that refer to the World War I, and they have been described as very efficient in terms of the power output, right? In terms of the weight, the cost, manufacture, easy to manufacture, and its reliability. Right? So the rotary engine met these goals with Genome Omega number 1 rotary engine, as shown in figure 4.2 in the next slide as an example. The entire engine rotates with the propeller, providing plenty of airflow for cooling, regardless of the aircraft forward speed. Okay, because the engine itself is also rotating. Some of these engines were two-stroke design, giving them a high specific power as well as the power to weight ratio. And this is the type of rotary engine conventional type that I'm talking about, where you can see that engine number 1, it is moving from this. Let's say the rotation is what we call it as a clockwise, right? So from station 1 over here, it's already moved to station 1 up here. So it is basically moving that way. So the whole engine is moving together with the propeller. All right. Unfortunately, what happened is that the severe gyroscopic effect from the heavy rotating engine made the aircraft very difficult to fly. You can imagine you have to make sure that it is at the same control, and then it has a lot of vibration. You can see that the engine consume large amounts of castor oil, which spread all over the airframe, which creating fumes normally will create the pilot to get dizzy. And the engine designer had always been aware of the many limitations of this type of rotary engine. The next one is Wankel engine. What is a Wankel engine? Wankel engine of a piston type of engine is a type of internal combustion engine using an eccentric rotary design. So the rotor itself, when it rotates, it is like this. So it will go rotate inside the rotor housing using reciprocating piston. So it basically designed to convert pressure into rotating motion instead of using reciprocating piston as shown in this figure, right? So in more detailed explanation, it's 4-stroke cycle, for example, being shown here from when it is at the intake position, okay, and then the air being compressed, and then the exhaust, and then the ignition. So this is the 4-stroke movement. You can see that the green triangle move in the housing, and it creates air going into the system, compression happen, exhaust, and ignition. So it takes place in the space between the inside of an oval-like epitrochoid shaped housing and a rotor that is similar in shape to a Relox triangle, but with sides that are somewhat flatter. All right. So the very compact Wankel engine delivers smooth, high revolution per minute power. It also has high horsepower per displacement compared to other internal combustion engine. In other words, the lubrication system is similar to that of the 2-stroke engine, and thus it does not need a separate system like the 4-stroke engine. Wankel engine is considered optimum power plant for light aircraft as it is light, it is compact, and almost vibrationless compared to the conventional type of rotary engine, which also provided high power to weight ratio. Further aviation benefits of a Wankel engine includes that the rotor cannot seize, since rotor casing expands more than the rotor itself. It is also not susceptible to shock cooling during descent and does not require an enriched mixture of cooling at high power. So the first Wankel rotary engine aircraft was the experimental Lockheed Q-Star civilian version of the United States Army Recon QT2 in 1967. You may want to Google it in the internet to see how it looks like. It was later on installed in a variety of aircraft, including Diamond DA-20 and general aviation aircraft designed for flight training. All right. So moreover, Wankel type of engine also being used in application of UAV, because it is compact in size and quiet in operation. Normally, it is being a suitable candidate to be the power plant for drones or UAV. Example here, AAI RQ7 Shadow, right? So it is installed at the rear stage where there is a propeller there being hooked to the piston Wankel engine. Wankel engine are also popular in terms of the home-built experimental aircraft such as the light aircraft ARB Super 2 powered by liquid-cooled Midwest AE1110 twin rotor Wankel engine. So this is experimental aircraft applying the Wankel type of engine. So since Wankel engine operates at relatively high rotational speed with relatively low torque, propeller aircraft must use a propeller speed reduction unit, right? They must use the PSRU to keep their propellers within the proper speed range. For instance, the Midwest twin rotor engine, which will be shown in figure 4.5, has a 2.95 ratio to 1 reduction gearbox. So Pratt & Whitney Rocketdyne developed a diesel Wankel engine for use in a prototype vertical takeoff and landing flying car called the Transformer. Right, you can Google that. The engine based on an earlier UAV diesel Wankel concept called the Enduro Core. Right. So let us move into the next type of piston engine. First one is rotary. And rotary divided into two, the conventional and the Wankel. Now we want to move into the reciprocating engine. So based on cylinders arrangement, and the reciprocating engine can be divided into 6 types. We have inline type of engine, we have horizontal opposed engine, the V type engine, the X type engine, H type, as well as the radial type of reciprocating engine. Okay, let us go through one by one. The first one is the inline type of engine, and this type of engine has cylinders lined up in a row, one row like this, and mostly it has even number of cylinders. So 4 cylinder straight engine scheme, right? So this is just a schematic diagram. Again, you may want to Google it and Google how is it look like in the real situation. So many inline engines were developed during the World War I. Same type of at the beginning of the era for piston engine, like Hispano-Suiza engine as well as Benz BZ4. So the biggest advantage of an inline engine is that it allows the aircraft to be designed with a narrow frontal area for low drag. And the cylinders are either upright, above the crankshaft, or inverted, that is below the crankshaft. Example for inverted inline engine is Menasco Pirate Model C4. The purpose that I didn't put it here because it's going to create a lot of going to be heavy in terms of my presentation. That's why I try to limit in terms of the figures, so to allow you to try to Google on your own to see what is the engine look like. So this type of engine, inverted inline engine, allows the propellers to be mounted up high for ground clearance and good visibility for the pilots. However, there are disadvantages of inline engine, which include poor power to weight ratio because the crankshaft and crankcase are long. Of course, it will be very heavy for type of aircraft. An inline engine may be either air-cooled or liquid-cooled. It can be either one, but liquid-cooled is more common because it is difficult to get enough airflow to cool the rear cylinders directly. That's why in the design of the inline engine, they normally use liquid cool to make sure that all of the cylinders are being cooled directly. Inline engines were commonly in early aircraft, including the Wright brothers. However, the inherent disadvantages of the design soon become apparent, and the inline design was then abandoned because and it become very rare in modern aviation. The next one is horizontally opposed engine. Okay, for reciprocating engine type, a horizontally opposed engine, also called a flat or boxer engine. You may want to Google that and to see how it looks like, and it has two bank of cylinders on opposite side of a centrally located crankcase, and the engine is either air cooled or liquid cooled, but air cooled version normally predominate. Is opposed engine are mounted, and the horizontally opposed engine are mounted with crankshaft horizontal in airplane, but may be mounted vertically in helicopters. So some application also have been installed in the helicopters. Engine is streamlined, resulting in less drag and good visibility for pilot, which is very important due to the cylinder layout. The reciprocating horizontal opposed engine tend to cancel, resulting in a smooth running engine. Opposed horizontal engine are air-cooled. 4 and 6 cylinder piston engines are by far the most common engine used in small general aviation aircraft, requiring up to 400 horsepower, up to 300 is equivalent to 300 kilowatt per engine. Example, Continental 0360. This is a good example for horizontally opposed engine. Right, we move on to the third type of reciprocating engine, the V-type engine. So cylinders in this V-type of engine are arranged in two line bank. Normally it's tilted like this, 30 to 90 degree apart from each other. So the vast majority of V engines are water cooled. The name V because the engine is being arranged in such manner in the V shape. The V design provides a higher power to weight ratio than an inline engine, which while still providing a small frontal area. And why small frontal area? Because a smaller frontal area, the smaller drag of the aircraft, especially at the front part. Perhaps the most famous example on this design is the legendary Rolls-Royce Merlin engine. You may want to Google this. Rolls-Royce Merlin engine. So which we normally being used as example like the Spitfires. Similarly, two types of V-type of engine, namely upright V-type as well as inverted V-type. They have this type as well as this inverted V-type, and frequently seen in the World War I engine. Next one, the X-type. So just now the V-type, now we have the X-type of engine. The X engine comprises twin V-block engine horizontally opposed to each other, and thus the cylinders are arranged in 4 banks, driving a common crankshaft. And Rolls-Royce Vulture is an example for this type of X engine, which powered Avro Manchester bomber as well as the Hawker Tornado fighter. All right. The next one is H-type of engine. We already talked about V, X, and now the H-type of engine. We call it as a H engine or H block. Is an engine configuration in which the cylinders are aligned so that if viewed from the front, if you look from the front of the engine of the aircraft, you can appear it to be vertical or horizontal letter H. So you can see that it is being arranged as such. The H engine can be viewed as two flat engines, one atop or beside the other. Right? The two engines each have their own crankshaft, which are then geared together at one end for power takeoff. Example, Napier Sabre was a British H24 cylinder liquid-cooled piston aero engine built by Napier and Son during World War II, which powered the Hawker Typhoon aircraft in the mid-1941. And then the last one of reciprocating engine is the radial type of engine. Okay, So this type of engine has 1 or 2 row of cylinders arranged in a circle around a centrally located crankcase as shown over here. This is a figure 4.7 showing single row radial type of engine. So each row must have an odd number of cylinders in order to produce smooth operation. Rotary and radial engine look strikingly similar when they are not running and can easily be confused. So earlier we talked about rotary engine, and you can see also the same shape of engine, okay? But the radial type of engine also looking the same, since both have cylinders arranged radially around a central crankshaft. Unlike the rotary engine, okay, the comparison is that the radial engine use a conventional rotating crankshaft in a fixed engine block. Okay, however, the radial engine has only one crank throw per row and a relatively small crankcase, resulting in a favorable power to weight ratio compared to the conventional rotating crankshaft of engine. Because the cylinder arrangement exposes a large amount of the engine's heat radiating surfaces to the air and tends to cancel reciprocating forces, radials tend to cool evenly and run smoothly. Okay, so the lower cylinders which are under the crankcase may collect oil when the engine has stopped for an extended period with a possible hydrostatic lock. Okay, in military aircraft design, the large frontal area of the engine acts as an extra layer of armor for the pilot. However, the large frontal area also resulted in an aircraft with a blunt and aerodynamically inefficient profile. Okay, so what we can do is that we want to stop here for a while. Okay, so that I would like you to we have a short break. Okay, we have a short break first before I continue the third type of aero piston engine. Okay, so we can have a short break and we can continue back. But meanwhile, if you have extra time, you can also try to Google all the examples of engine that I have already highlighted from the earlier of the presentation today. There are a few examples of aircraft that I purposely do not put the picture. Okay, you may want to Google it for your own consumption. You can see and appreciate more in terms of the application, how it works, how it looks like, and the moment you do that, you basically get more information. All right, so I believe we can have an early break, about 10 minutes.